The TRIZ 40 Inventive Principles. Genrich Altshuller, creator of the theory of inventive problem-solving, better known by its Russian acronym TRIZ, analyzed thousands of patents and identified a group of 40 techniques that inventors used successfully to solve problems across different fields. To inspire new inventors in their problem-solving, I created this video illustrating one of these principles. Principle 35. Parameter changes. Change an object's physical state, for example to a gas, liquid, or solid. For example, ejector seat. The seat is propelled out of the aircraft by an explosive charge or rocket motor, carrying the pilot with it. Change the concentration or consistency. For example, powdered paints. Nexiva can be easily transported as a powder and store it for a long time. To get ready to paint, just add water.
Wacker's new Nexiva product line offers dispersible polymer powders that can be used to manufacture interior wall paints in powder form. This technology enables reduced weight and biocide-free powder-based wall paints that offer key storage and transport advantages. Powder paints remain stable, even without the addition of preservatives. To redisperse the Nexiva-based powder paint, water is added just prior to application to the wall, therefore eliminating the need for adding biocides during production. If necessary, small amounts can be stirred or shaken by hand.
Change the degree of flexibility. For example, non-Newtonian fluid damper. Steady wears steady one is embedded with a non-Newtonian fluid that stiffens instantly in the presence of tremors to provide an equal and opposite force while allowing voluntary motion.
I have a family history of essential tremor. By the time I got to my 40s, I was as bad or worse my dad was when he was in his 60s.
The minute John tried the glove on, the effects were instant and amazing. Actually, he was able to write again. He was able to conduct, simple activities. It was very emotional, and John was very happy, as was I.
Just the day-to-day function of being able to eat and shave without worrying about cutting myself. So it's been a real life changer for me.
In structural engineering, I learned how to stabilize buildings against wind or earthquakes. So taking inspiration from that and applying it to this, that's how it came about.
Change the temperature. For example, freeze drying. Freezing drying sublimates the moisture out the food, which maintains better the food flavor, color, and nutrition.
The freeze dryer freezes the food to 40 degrees below zero. The vacuum pump automatically turns on and creates a powerful vacuum around the food. As the trays gradually warm, while the food is still frozen, a process called sublimation occurs, which removes water from the food. This is what allows the food to keep its original shape, flavor, and nutrition. The process takes between 20 to 36 hours. Smart sensors determine when the food is completely dry and alert you with a beep. The process is entirely automatic.
Change the pressure. For example, metal impregnation process. This refers to the sealing of porosity which occurs in casting. Through vacuum and/or pressure methods, polymer resin is forced into the porosity and then cured to form a pressure-tight part.
Is a sponge-like area in an otherwise sound metal part. Casting porosity has always been a problem and can often result in leakage of fluids and gases unless properly treated. ISL's streamlined process efficiently seals all open porosities. A basket with components is placed in the impregnation autoclave. A high vacuum is applied, withdrawing the air. Resin is released into the autoclave, covering the components. Open porosities are filled with resin due to the reduction of atmospheric pressure. Vacuum is replaced with positive pressure to ensure that even the smallest pores are completely filled with resin. Excess resin is sent back into storage. The components are drained and a centrifuge cycle spins excess resin from the surface of the parts. Turning the basket and immersing in water multiple times, any remaining resin is washed off. The resin inside the pores is then cured in a hot water tank, quickly polymerizing the resin into a homogeneous material, permanently taking on the size and shape of the porosity. The finished components can now be leak tested or assembled directly.
Change other parameters. For example, shape memory alloy. This alloy can resist about 30 times the deformation of a conventional material.
This particular tire, unlike a conventional spring tire made of spring steel, is different because the material that it's made from is an alloy based on stoichiometric nickel titanium. And this particular material doesn't deform like conventional materials, where in those materials, when we put stress on them, we basically are stretching the bonds between the atomic structures. This material has a unique characteristic that allows it to do an atomic rearrangement to accommodate deformation. And that lets us do about 30 times the deformation we could do in a conventional material without having permanent deformation happen. We could actually deform this all the way down to the axle and have it return to shape, which we could never even contemplate in a conventional metal system.
Share this video and add your examples of this inventive principle in the comments below. Parameter changes. Change an object's physical state, for example to a gas, liquid, or solid. Change the concentration or consistency. Change the degree of flexibility. Change the temperature. Change the pressure. Change other parameters.